Hello and welcome back to Math 121. This is a video over section 1.5 and we're going to be talking about quadratic equations. So we're going to be solving quadratic equations by all of the methods. Okay, the first one we have is factoring. The second one we have is the square root property. And then we complete the square, and then we have the quadratic formula. So these are the four methods that you can use. Oftentimes factoring is the fastest, and depending on the type of equation you have, using the square root property can be just equally as fast. Completing the square and the quadratic formula are essentially the same thing, but these are primarily used when you have no other options, if you can't factor and you can't use the square root property. So we have to know all of the methods, because we're going to have to be solving quadratics. And so when we solve quadratics, quadratic equations, the first thing that I want to talk about is that a quadratic, when we're solving this, a quadratic is, let's write this down, a quadratic is a parabola. Okay, so when we have a quadratic equation, it takes the shape of a parabola, okay? And we want to, what we're really looking for is we're looking for where the parabola crosses the x-axis, okay? And that is something, this is a way to check. All right, and what we're going to do is we're going to use our calculators. We'll use Desmos, but we'll also use graphing calculators because we need to know how to use those for exams and stuff like that. So I'm not necessarily going to go over that in the videos, but I will kind of talk about this for a couple of them. So let's just talk about general. What it is that we're doing. So a quadratic equation, all right, so a quadratic equation takes the form, has the form of ax squared plus bx plus c, okay? And when we're solving this, we set this equal to 0. Okay, so the first thing that we always need to consider is that we first set the quadratic equal to 0. All right, that's the first thing that we do, equal to 0. All right, and we'll kind of talk about more as to why we do that, but that's what we do. Now, I first want to talk about solve by factoring, okay? So solve by factoring. And I want to use the zero product principle, okay? So we'll talk about the zero product property. And so let's think about this. The zero product property says this. If I take some value A times some value B, and we get a result of 0, okay? So if I take two things and multiply them and we get 0, then here's what I know. That A equals 0, or I know that B is equal to 0, okay? This is really, really important because this is what we're going to do when we solve by factoring, okay? So I want to talk about that real quick. The other thing that I want to talk about is, kind of the square root property. So solving by the square root property. okay? And let's think about this. Let's say I have x squared is equal to the number 4, okay? When I have this equation, I'm solving this for x, and I'm saying, okay, another way to think about this is x times itself gives me 4. So what numbers could I multiply by themselves to give me 4? And the answer to that question is that x could equal 2, or x could equal negative 2, okay? If I take 2 times 2, if I do 2 times 2, I get 4, okay? Or if I did negative 2 times negative 2, that's going to give me 4, all right? So when I'm solving these equations here, that's something we have to consider. That when I square something, it's always going to make that value positive. So when I do square something, I can square a positive number, okay? And that'll give me my value 4. Or I could take, square a negative number, and it'll still give me a positive value. So when I solve this, the opposite of squaring something is taking the square root. So I would just do this first step here to solve that. And when I apply the square root, the square root of 4 is 2, but I have to remember that when I'm solving a quadratic, which is, just something squared, I have to account for the positive and negative value, okay? So this is really important that when you apply the square root property, apply the square root, you get both positive and negative answers, okay, or solutions, all right? So however you kind of want to look at that. All right, so there's that. The next thing I want to talk about, and then we'll move on, is the idea of an imaginary number, okay? Now, we're not going to see this right now in this section, but in one of the examples, we will see it. So an imaginary number is this. The issue is that if I take, say, the square root of a negative number, like negative 1, I can't do that, okay? Taking the square, when you take the square root, it's the opposite of squaring something. So, what two numbers are going to multiply together to give me a negative number? And you can't, okay? You have to think about, if I take, say, 2 squared, I'm going to get 4. If I take negative 2 squared, I'm still going to get 4. Now, if I go the opposite way and take the square root of 4, I'll get both, the positive and negative value, okay? So, but the issue is that because whenever I square something, it becomes positive, I can't take the square root of a negative number. So what I get here is I get this imaginary number I, okay? And what we did was we had to create that number. We said, all right, well, even though we can't physically take the square root of a negative number, let's say that we can, and let's give it a value of I. This actually has a lot of applications in electronics and computing. So like without it, we wouldn't have our cell phones, and I couldn't be making this video. And the electricity processes that we know of wouldn't be as sufficient and cool. So there you have it. So that's what we're going to do. But I wanted to make sure that we talked about the zero product property, why that happens, and then the square root property and why we get positive and negative. We may or may not hit this very hard in this section, but I wanted us to at least see this, okay? So let's take a look at the first one, solve by factoring. Now what I have, whenever you have a quadratic, okay, like this, we solve it. First of all, it's set equal to 0, so that's good. We have that part taken care of. The next thing I want to do is say, okay, well, can I factor this? Is this a factorable quadratic? And just because I have two terms here, it is. So what I can factor out from each of these terms is a 3 and an x. And then I'm left with an x minus 3, and that's equal to 0. Okay, now I have factored it. I have one quantity here, 3x, times another quantity, x minus 3, and that's going to be set equal to 0. Once I have factored this, what I do is I take each of my factors and I set them equal to 0. So I'm going to take 3x, set that equal to 0, and then I'm going to take x minus 3 and set that equal to 0, and then I'm going to solve. Okay, and so I'm going to divide both sides by 3 here and here. 3's divide out. 0 divided by 3 is just going to be 0, so I get x equals 0. Here I'm going to add 3 to both sides, and so I get that x is equal to 3. Now, both of these numbers are my solutions, okay? And I'm done. Now, the only thing I do want to do is I'm going to go in and graph this in Desmos just to show you graphically what's happening. Okay, and so since I've graphed this, all I'm doing is just graphing the 3x squared minus 9x. And what it's doing is it's crossing the x-axis at 0, okay? And then the y, and then over here, the x-axis at 3. So 0 and 3 are the values that I'm looking for. So you can check yourself graphically, however, you do need to do it by hand, okay? So this is more of a way to check to see if you're right. And sometimes, you can start off with this to help you be like, okay, I know what my answer is. Now let's factor it to get there, okay? All right, so now let's move on to the next one. Now this one's a little bit tricky. 2x squared plus x equals 1. Now I want to solve it by factoring. First thing I want to do is set this equal to 0. So I'm going to subtract 1 from both sides, okay? And I'm going to get 2x squared plus x minus 1 is equal to 0. Now because I have a leading coefficient of 2, okay, I'm going to factor using the box method, okay? So I'm going to draw my little box, okay? I'm going to put 2x squared here. I'm going to put negative 1 here. And then I'm going to put two numbers that multiply to 2x squared is 2x and an x. And then I want to do, to get negative 1, I need to do positive plus or minus 1. So let's do a positive 1 here, and let's do a minus 1 here. So I get positive 2x here, and I get a negative x from here. Combine my like terms, and this is just going to give me x, which is what I'm looking for. Okay, so this is good. So at this point, what I've done is I've factored this, and I'm going to write it out like this. I'm going to do 2x minus 1 and x plus 1 and set that equal to 0. Then what I do, just like in the other one, I take each of my factors and set them equal to 0. So I'm going to take 2x minus 1, set it equal to 0. And then I'm going to take x plus 1 and set that equal to 0. So I'm going to add 1 to both sides here. So I have 2x is equal to 1, divide by 2, divide by 2. So I get that x is equal to 1/2. Here I'm going to subtract by 1 from both sides. And so I get that x is equal to negative 1. Okay, so here are my answers. X equals negative 1, x equals 1/2. Okay, and that's how I solve. Okay, now we could graph that. I'm not going to graph that right now, but that's how we would go about doing that. Okay. All right, the next one here is to solve by the square root property. So notice here, the difference between, this problem here and this problem here, because they look very similar. This one has a single x squared, okay? This one has two x's, okay? Two terms that contain an x. Okay, this one also had two terms and then a constant that contain an x. But only when I have a single x squared is when I want to use the square root property. Okay, I wouldn't use factoring on this one. Okay, so let's do this. What I'm going to do is I'm just going to isolate x squared. So we're already set equal to 0. I'm going to add 21 to both sides. Okay, and so now I've got 3x squared is equal to positive 21. Okay, I can isolate x squared by dividing everything by 3. Okay, and so I get that x squared is equal to positive 7. Okay, now what I can do is I can apply the square root property. Okay, because I just have a single x squared equal to a number, I can just do that. All right, so now I have this. I have x is equal to plus or minus the square root of 7. Now the issue is that I can't evaluate the square root of 7. I also can't simplify it at all, so I'm just going to leave it like this. Now you can leave your answer like this. This would suffice, or you could say that x is equal to the square root of 7. And I could say that x is equal to the negative square root of 7. okay? And the square root of 7 is just a number. You know, it's like 2.3 or something like that. Or no, probably like 2.6 or something like that. But anywho, it's a number, okay? If you did this in the calculator, you would get a decimal value, and what you would do is just take the square root of 7 and hit enter, see what the numeric value is, and see if that matches up, okay? All right, so now let's take a look over here. Now this one's a little bit different, and the reason why is because of this. Because if I isolate my x squared, let's look at what happens. If I subtract 45 from both sides, okay, I'm going to get 5x squared is equal to negative 45. Okay, and then I'm going to divide by 5 on both sides. So then I get the value x squared is equal to negative 9. Okay, now when I apply the square root here, because I just have an isolated square root, the issue is that I am taking the square root of a negative number. All right, so what's going to happen is this. I get x is equal to plus or minus the square root of negative 9. A couple different ways to think about this, but the fact of the matter is that I'm taking the square root of a negative number. So because I'm taking the square root of a negative number, I have to account for the imaginary component. All right, and here's what I do. I split this up. I do, okay, x is equal to plus or minus. I write this out as the square root of negative 1 times the square root of 9. Now the square root of negative 1 is I. So I get x is equal to plus or minus I times the square root of 9 is 3. Okay, so here's how I'd write my answer. I would write my answer as x is equal to plus or minus 3i. All right, now you could write this as x is equal to 3i and x is equal to negative 3i. All right, either one of those is going to work, but that's how I want to write my answer. Now here's the issue, okay? If you tried to graph this, okay, this would not hit the x-axis, okay? Therefore, we don't have a real numbered solution. We had to come up with an imaginary solution so that algebraically we could do this problem, okay? And that's the idea. All right, now part C, these problems are a little weird, but I like them, okay? Because I have some quantity squared here, okay? And what's nice about this is that my first step here is automatically I'm going to take the square root of both sides. Because when I'm taking a quantity squared, the opposite of taking something squared is to take the square root. And I can automatically, in my first step, just get rid of that square, and I have x plus 5 is equal to plus or minus the square root of 11. Now, because 11 is a prime number, I can't simplify that. I'm just going to leave it as the square root of 11. And then my next step is going to be to subtract 5 from both sides. And so I get that x is equal to negative 5 plus or minus the square root of 11. And that's my answer. Okay, and so what you have to think about is, even though that's a weird way of like writing something down, you've got x is equal to negative 5 plus the square root of 11, or you have x is equal to negative 5 minus the square root of 11. Okay, this is going to give you some weird decimal. Okay, negative 5 plus the square root of 11, you know, square root of 11 is a decimal number. You can plug this into the calculator and get a value, and you can check to see, you know, what you get. But that is, you know, that's your answer. All right, so those are pretty self-explanatory ways and things that we've done in the past. Okay, now I want to talk about completing the square. Completing the square is a process, okay? So it's important that we, you know, go through this, you know, with me, and, you know, we do our best. All right, so I'm going to write this down as x squared, what is this, plus 4x minus 1? Okay, and the issue with this one is that, you know, I look at this problem, I kind of already know that I can't factor this. Okay, so if you're given a quadratic and you're trying to solve it, one of the ways that you do this is you look at it and you say, okay, can I factor it? Because otherwise, it's pretty easy to do it by factoring. And it's pretty, you know, it goes pretty quick. But if you can't factor it, one of the options you have is completing the square, okay? So what I'm going to do is this, all right? I'm going to first move my positive one, this negative 1 to the other side of my equal sign. And I get this, okay? I'm going to take x squared plus 4x plus blank is equal to 1. And if I'm going to add some blank in here, I need to do the same thing over here, all right, plus blank. Okay, now, what's going to go into this blank is done by the following, okay? I'm going to take my middle term, okay, which is 4, okay, 4x, or just the coefficient, my middle term. So I'm going to take 4, I'm going to divide it by 2, and then I'm going to square it. Okay, so 4 divided by 2 is 2, okay, and that's going to be an important number later, and we're going to square it. And then 2 squared is just going to give me 4, okay? So 4 is going to go here, and it's going to go here. Now, over on the right side, you know, let's just kind of rewrite this again. I've got x squared plus 4x plus 4, and then I've got 1 plus 4, which is 5, all right? Now, here's what I can do. What I have here is a perfect square trinomial. Okay, and what that means is that when I factor this, I'm going to have 2 of the same factors. Okay, so if I factor this, I say, okay, what 2 numbers are going to multiply to 4 but add 4? That's 2 and 2. You can do the box method on here. But in any case, this is going to factor to x plus 2 times x plus 2, and that's going to equal 5. The act of taking my middle term here, dividing it by 2, and then squaring it is going to give me a perfect square every single time. And what's going to happen is I'm going to get, you know, I can write this as x plus 2 quantity squared is equal to 5. This is the whole point of this. This will allow you to solve any quadratic no matter what, okay? And the cool thing is that you're always going to get this sum quantity squared. So then you can apply the square root property and solve this, okay? But it's this act of creating this. You have to come up with this, all right? And the way you do that is you take your middle term, divide it by 2, and then you square it, and then you're good. Now notice something. Notice how I said let's make sure that this number 2 is going to be, you know, there, all right? That's going to be an important number. Look what number is here, okay? So there's a trick to this because some of these will get very difficult to factor and you're going to have a bunch of fractions in there and it's going to really kind of be a pain in the butt. But if you remember this, that if you, well, you know, whatever you take the middle term, divide it by 2 and then squared, whatever you do, when you take this middle term and cut it in half, this number is going to pop up here, okay? So it does become a pretty easy thing to factor if you notice that, okay? If you don't, this is going to be a difficult process for you, okay, when these problems get a little tricky, all right? So anywho, okay, when we'll have time to talk about that in class and practice it, but here's what I've got. I've got x plus 2 squared is equal to 5. This I can now solve, and I can apply the square root to both sides, and here's what I get. I get that x plus 2 is equal to plus or minus the square root of 5. And then what I'd want to do is I'd want to subtract 2 from both sides, and I would get that x is equal to negative 2 plus or minus the square root of 5, and this is my answer, okay? Notice how it didn't come out nice and neat, and that's because it doesn't factor, okay? Sometimes these do come out nice and neat, but oftentimes they don't. So that's how we come up with, that's how we complete the square. All right, now let's look at the next page. This problem is going to be a little bit trickier, and it's going to involve a couple more steps. But it's going to be the same concept of completing the square. Okay, so on this problem, 2x squared plus 3x minus 4, we're set equal to 0, so we're already good. The first thing that we have to do is we have to have a leading coefficient of 1. Now, my leading coefficient, the number that's out front, is a 2. Okay, so what I'm going to do, the first thing, well, let me rewrite this down over here. I'm going to do 2x squared plus 3x minus 4 is equal to 0. I'm going to divide everything by 2. Okay, and what's going to happen is that, you know, these parts divide out. I'm simply left with x squared plus 3 halves x minus 2 is equal to 0. Okay, this quadratic here is the same thing we have here, except for I have a leading coefficient of 1. Okay, this one had a leading coefficient of 2. And now I have a fraction here, okay? And so this is going to be a good problem. Make sure that you guys pay attention to this part of the video because this will help when we are completing the square. Now, what I'm going to do is I'm going to do the same exact process as I just did. The only difference is that we're going to be dealing with some fractions here, okay? So, pause the video, rewind, rewatch. Okay, my hope is that we can get through this problem and that, after watching this, you know what to do, okay? If you have to stop and pause and write other things down, write down step by step. How did I get this? What's the point of this? Okay, now is the time to take some good notes, all right? Okay, so what I got here is this. I've got, I'm going to move over my -2. So I'm going to add 2 to both sides, okay? And what we're left with is x squared plus 3/2 x plus blank is equal to 2 plus blank. Okay, so now I have to figure out what's going to go in this blank. I need to turn this into a perfect square trinomial. So same thing that I did before, okay? I was going to take my middle term, which is 3/2, okay, the coefficient, 3/2, and I need to divide this by 2. I'm going to write it like this because we're dealing with fractions, and then I'm going to square it. Now, dividing fractions means I am also multiplying by the reciprocal, okay? So I'm going to write this as 3/2 times 1/2 squared, okay? And then I'm going to do this. I'm going to do 3 times 1, which is 3, 2 times 2, which is 4, so I get 3/4, and then squared, okay? This number, 3/4, is going to come in very handy later, okay? Now, when I do this, I'm going to take 3 square it, 4 square it. I'm going to get 9/16, okay? This is the number that I'm going to put in my blanks, okay? But we're going to have to come back to the 3/4. All right, so let's do this. I'm going to put in 9/16, okay, here, and I'm going to put it here. So the first thing I want to do is I'm just going to rewrite this part over here. I've got x squared plus 3/2 x plus 9/16 is equal to, and I'm going to do this. I'm going to do 2 over 1. All right, and I'm going to get a common denominator. So I'm going to multiply this by 16/16. And so this is going to give me 32. Yep, 32/16 plus 9/16. Okay, and let me write this up over here. Okay, so I've got x squared plus 3/2 x plus 9/16, okay? And then what I'm going to get is I'm going to get 32/16 plus 9/16 is 41/16, okay? And that's that. Now, what I have over here on this left side is a perfect square trinomial. I want to find 2 numbers that are going to multiply to 9/16, but at the same time add to 3/4, okay? That magic number is 3/2, is 3/4, okay? So here's what I'm going to do. When you have fractions like this, I'm going to go from this step to the next step, which is simply going to be x plus 3/4 quantity squared. Okay, believe me, this factors to this. You can multiply it out, and we might try a couple of these in class, but that's the idea, all right? And then that's going to equal 41/16. Now, what I'm going to do is I'm going to apply the square root principle. Okay, take the square root of each side, and here's what I get. I'm going to get x plus 3/4 is equal to plus or minus, and when I take the square root of a fraction, I'm going to do the square root of 41 divided by the square root of 16. Okay, I can't take the square root of 41, but I can take the square root of 16. So I get the square root of 41 over 4, and that's going to equal x plus 3/4. Now, I'm going to subtract 3/4 from both sides, okay? And here's what I'm going to get. Okay, up here, I'm going to get that x is equal to negative 3/4 plus or minus the square root of 41 over 4. Now, you can leave your answer like this. That's fine. Okay. However, you can also, because you have a common denominator of 4 between these two fractions, you can write this as negative 3 plus or minus the square root of 41 all over 4. And this would work as well. Okay. Now, finding a decimal approximation for this just would involve a calculator, but, leave your answers like that. Okay. So this is a hard problem. Okay. It took me a long time to get to the point where I could do this fluently without any sort of, issues. But we got to have a couple understandings. We got to be able to, operate with some fractions and do a couple things. Okay, so that's that. All right, now, completing the square is the long way of doing it. Quadratic formula is essentially using completing the square. So, given this, a quadratic in the form of ax squared plus bx. Let's use lowercase. If I have ax squared plus bx plus c is equal to 0, okay, a, b, and c are these numbers that are in my quadratics, right? Okay, if I want to solve this, and I can go through this with you as well, how we get it, but essentially if I use completing the square on this with these, with those, numbers, a, b, and c, I would get the following. And that's going to be x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and this is my quadratic formula. All right, this is a very powerful formula, one of my favorite formulas, and it's kind of hard to remember. Okay, but if you know Pop Goes the Weasel, it goes like this. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's one way that you won't forget it, all right? But that is the quadratic formula. All right, now what I'm going to do is solve the quadratic formula solve these quadratics using the quadratic formula, all right? And so let's watch what happens, okay? I need to list out my coefficients. I have my a value, I have my b value, and I have my c value. Now my a value is positive 2, my b value is positive 2, my c value is negative 1. And all I'm going to do is plug this into the quadratic formula. So x is equal to opposite b, which is 2, so negative 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times a, which is 2, times c, which is 1, all over 2a, so 2 times 2. All right, so now what I need to do is evaluate this, okay? All I need to do is now do the math, all right? So when I do this, x is equal to, I'm going to do negative 2 plus or minus the square root of 2 squared is 4, minus 4 times 2 times 1, so 4 times 2 is 8, so 4 minus 8, and then all over 2 times 2, which is 4. Okay, the next thing I'm going to do is do the operations inside of my square root, so x is going to equal opposite 2 plus or minus the square root. Now 4 minus 8 gives me negative 4, okay, all over 4, all right? So now, here's what I get. X equals opposite 2 plus or minus. Now the square root of negative 4 is going to give me an imaginary number. The square root of 4 is 2. The square root of a negative is going to give me an I. So I got negative 2 plus or minus 2i over 4. Okay, technically you could leave your answer like this. However, because you have 4 in a denominator, you can write this as x is equal to negative 2 fourths plus or minus 2i over 4. So negative 2 over 4 simplifies to negative 1/2 plus or minus 1/2 I. Okay, so you can write this a couple of different ways, but needless to say, you're not going to get numbers out of this. You're going to get imaginary numbers, okay? So, using the quadratic formula, otherwise, you can't factor this, okay? If you could factor it, we'd get nice and neat numbers, but we're not, all right? So let's take a look at the next one. Let's see what we get here. Let's see. All right, so I've got my a value is equal to 1. my b value is equal to -2, and my c value is equal to +2. So if I use a quadratic formula, x is equal to opposite b. If b is already -2, this is going to be +2, plus or minus the square root of b squared, so -2 squared minus 4 times 1 times 2, all over 2 times 1. So here's what we get. X is going to equal 2 plus or minus the square root. -2 squared is 4, minus 4 times 2 gives me 8. So we're getting the same, pretty much same thing here, all over 2. So I get x is equal to 2 plus or minus the square root of -4 over 2. When I do this, okay, square root of -4 is 2i, so x is equal to 2 plus or minus 2i over 2. Now, because you could leave it like this, but this one really simplifies down to x equals 2 over 2 plus 2i over 2. So 2 over 2 goes to 1, 2 over 2 goes to 1, so 1 plus or minus I is our answer, okay? And that's how we get that. So on the ones in the homework, I don't think that they have as many imaginary numbers, but that's the idea. All right, the last thing I want to talk about is the discriminant, okay? The discriminant is the part of the quadratic formula that's underneath your radical. So underneath the square root. So it's the b squared minus 4ac part, okay? Now, if your discriminant is positive, okay, this means that you get 2 real solutions, okay? Meaning that your graph is going to cross the x-axis twice, okay? If your answer is negative, okay, this means that you get 2 complex or imaginary solutions, okay, and cross my T. And what this looks like is that you have a parabola that doesn't cross the x-axis, okay? If you get 0 in your discriminant, okay, that means you have 1 real solution, okay? And what this means is that you have a parabola whose vertex is the only intercept of the x-axis, okay? And so that's the idea. So that's quadratics in a nutshell, guys. This is really fun. So it's a lot of steps, a lot of things going on, a lot of things to remember, but you've seen this before. And so, let's just go ahead and move on from there. Hope all is well, and we'll see you soon. Thanks. Bye!